Hi, everyone. I'm Anna Abramova, and welcome to this live session celebrating the release of second edition of the book Data Modeling with Snowflake. This is a best-selling book and a must-have for data leaders, data practitioners, anyone in data engineering, data architecture, and data management overall. Joining me today is the author himself, Serge Gershkovich. I guess the intention for today is to dive into the book's new content, all of the changes that Serge you implemented, also new trends in data modeling, especially in the era of AI. The book was born out of real pain. And I want to go back to that moment in time of kind of what motivated you in the first place to write a piece on data modeling.
Yeah, I can still remember that because different events in my life contributed to the culmination of, okay, this needs to happen. Number one was just me transitioning into data modeling the way many people transition into data modeling. Sure, data modeling is data, computer science, engineering, but when you go to university, you very rarely specialize in data. Most people don't. So most people do some kind of computer science, programming, and somehow end up in data, if at all, even if they even have that much of a formal background. A lot of people start in other science fields, physics, mathematics, statistics. Other people just business analyst. You manage an Excel, suddenly you're managing a dashboard and you have no formal background. So myself, I did have a computer science background, but that just meant I had SQL 101 under, as part of my university curriculum. The emphasis was not there on the rigor of data modeling. It was more on, just familiarizing users with SQL. And when I started working, it was kind of being thrown in the deep end, figuring things out, where you're under pressure to deliver, as anybody in a data team understands. There's not a lot of time in most cases. You don't really have a mentor usually, not a lot of time to really learn the fundamentals and do things right. So it's only after you've changed jobs or maybe worked alongside some more senior engineers and data modelers that you start to kind of get the big picture. So that was even on a personal level. On Once I joined SqlDBM and I began speaking to our customers and meeting people interested in data modeling, looking to implement data modeling. And a lot of them would come to me for that with that exact question in mind of maybe they understood it, but they were like, how can I introduce this to my business users? I'm a data engineer, so I know some SQL, but I don't know the fundamentals of building a data warehouse or structuring it or making sure that my solution is scalable. Can you recommend something? And at that point, it was very hard because data or information in this realm is very distributed. You have kind of your canonical texts like Kimball. You have more in-depth, kind of more data vault if you want to dive into data vault. You have just many data modeling books out there, but a lot of them kind of go for breadth. They want to cover as many conventions as possible, as many standards as possible to kind of give you that feeling of completeness, but end up kind of leaving you overwhelmed of, okay, there's so much out there, like which one of these standards am I supposed to be using? And most importantly, why? Like, why do this in the first place? A lot of these texts assume that since you've picked up the book, you understand why you should be doing modeling in the first place, where it fits into the data team and the organization as a whole. And that's absolutely not the case. Like some of the even the canonical texts are just so technical that there's zero there. Like even technical people would get lost if you pick up like something by CJ Date or something and you're new to the field, like you would just get left behind. And so I wanted to cover everything in a practical approach, starting with the why of what is data modeling and where does it fit into an organization in today's world? How can it help not just the team, but the organization as a whole, doing analytics, empowering our business users. Why should we care about this? And do it in a way that kind of just ramped up in terms of complexity, that it starts just with a simple business view of data modeling and then goes kind of transitions nicely from data modeling itself, from conceptual to logical to physical, then transformational, and ultimately leaves somebody that, first of all, they can get off the ride at any time. It's like if you're just kind of here for the business understanding, or as an end user, as an analyst, you understand the value and what your data team is asking of you, and vice versa. If you're new to Snowflake, if you're new to data modeling, if you want to go hands-on and not just stop at theory, but actually do the code, do the exercises of loading these dimensions and facts and tables, that you can go ahead and do that. You have the recipes, step-by-step guide, code you can follow along with, tweak. And it was, again, for me, it was a complete solution that just didn't exist. I couldn't recommend a book like it because one didn't exist. And in the end, that's kind of common writer advice, like write for yourself or write for one specific person, and there will be others with who that resonates. So I was very fortunate that it was indeed a view and a
Got
perspective that resonated with the rest of the community.
Okay, and so just to formalize, I guess it's a formal way of introducing the audience to data modeling, no matter their background or how beginner or not they are, but still keeping it open to a wide range of the audience, and also having it more on a practical side rather than going too much into the theory. Although you do have theory in it too, but I feel like it's a good mix
Yeah,
between the
absolutely.
two.
Like I said, it's an increasing slope of complexity, since again, at the end of the day, theory will only get you so far. You have to actually know
Mm-hmm.
how to implement this. And this was one of the reasons where I said earlier, people said I was crazy for writing a book, a data modeling book, which is a very generic kind of all-encompassing
Topic.
science
Yeah.
for Snowflake specifically. They said, a type 2 dimension looks the same on Snowflake as it does on SQL Server. And that's absolutely true. However, knowing the architecture of the platform you're going to be working with is equally as important, because there are efficiencies, tips, and tricks for every single platform out there, Snowflake, whatever you're using, any database. And there's a better way and a worse way to build. You can build a generic type 2 dimension. I'm sure that'll work anywhere. But you can make one more cost effective utilizing Snowflake's tool set or Oracle's tool set or what have you. So I just wanted to pick something that would, number one, be accessible to everyone, as Snowflake is. You can, if you want to follow along, you don't need a corporate account. You don't need a credit card even. Just go to the Snowflake website, request a trial, and follow the examples. But also it's a two-in-one that many people will be new to the platform as well. Maybe they're not new to data modeling. Maybe they want kind of that intersection of what they already know in the theory tied to very specific formulas and recipes that apply to Snowflake, which maybe they are unfamiliar with, because again, it is a cloud data platform, which many people are encountering for the first time if they're transitioning from on-premise systems. We can obviously we're going to get into some of the implications of SaaS and cost and cloud FinOps, which kind of really change the transformational and the modeling game on its head, because one of the reasons again why data modeling is such a hot topic right now is because previously, once you bought a server on premise, you had that machine. Like you would never exceed the costs of what it cost you to buy that machine, the licenses, etc. If you built something inefficient, worst thing that can happen is your users are going to be sitting waiting for a query to execute longer than it needs to. But your CFO will never come after you and say, like, what is this bill for $100,000 when you had a budget for 20? But on a cloud data platform, that can very easily happen if you're not careful and you don't know what you're doing. So it was a really good chance to bring those two together and really underscore why this is important and why you need to build this right and scalable, and make sure that, again, these things don't happen overnight, that you need to plan for the eventualities, and you need to, by definition of you're building something that's going to grow. if you expect the company to grow, you should expect your data footprint to grow and your data architecture to grow. So it needs to scale by nature.
Why should, and I know all of these questions are answered in the first edition. So for those who are familiar with the first edition of the book, why should they read the second one? What did you add? Like which topics have evolved since that time?
Yeah, planning before you build, like that was a big thing back in the day. Now you don't need to do that. You just go off and do whatever. That was a big, no, obviously not. The fundamentals don't change. So one of the great things about writing a data modeling book is it really gives you the perspective of data modeling is as old as computer theory almost. It's as early as the 1960s and 70s, people were already thinking about formally defining data structures, whether through math and symbols, before they actually start loading bits and bytes into a database or what a database even is. And very little of that has changed. So the notation, the symbols, the frameworks that we use today, you they haven't really been innovated since the 80s because they're common sense things that really there's nothing more to add there. But we are dealing with technology, Snowflake
Snowflake itself.
specifically.
Yeah.
Exactly. And Snowflake, as we know, is on a rocket ship ride to the moon, and they're constantly innovating. They're constantly adding new features, new objects, new ways to analyze data, new ways to load and process, and AI, I guess we'll definitely talk about because AI is a multifaceted thing. It's AI embedded in the platform in terms of being able to do natural language processing on the data itself, like even within a row, but also then building architectures that are AI friendly, that making sure that, again, AI is not going to do magic for you if you create a mess and have it try to guess and reinterpret and read between the lines of what does it mean when you say client, is the table actually called customer and things like this. But we'll talk about that separately. And this is the part that for me was the most exciting. That number one is the obvious that the new edition had to address all of the new Snowflake objects. There's a part on semantic models and how they are playing an increasing, a very important role in Cortex and AI analysis in Snowflake. And there was also this was something that I kind of feel guilty for leaving out of the first edition, but it took me time to realize of first of all its significance and why it needed to be in the book. And I'm referring to the business value of data modeling. And not just saying it's important because it helps build scalable systems, it helps us communicate with the business. That's all covered in the first edition. But I realized in speaking with our clients and some of the people that I get to interact with as head of product at SqlDBM, I get the privilege of seeing people embark on their data modeling journey, coming from no modeling or coming from some other tool. And unlike a data architect who has maybe one use case through the years that they're working at a company, or even a consultant who might be seeing several use cases in a given year, I'm talking to, dozens of people a month and not just seeing them at a point in time, but almost like a cohort. I get to see them as they're starting out, as they've been on the journey for 6 months, 1 year, and even those that, don't succeed, that come back and say, sorry, we tried. We couldn't make this data modeling thing work. And there I started to see some patterns and red flags. And they were very counterintuitive because a lot of these people that came back a year later and said, you know what, we're moving away from data modeling as a company. These were not the newbies that, had no idea what data modeling was. Like these were seasoned veterans. So for me, it was really curious to speak to them and dive deeper and say, okay, what happened? Like you know more about data modeling than I do. And you know what the answer was? The answer was they didn't know how to talk to their business teams. They were eating, breathing data modeling all day long. They understood all of the conventions, the rules, the frameworks, but they could not get their business stakeholders to care and to put in the time to collaborate with them. So a data modeler at the end of the day doesn't own the data model. That comes from your business stakeholders. We just formalize it and build it out and physicalize it. But if fundamentally nobody's willing to put in the time to sit down with you and validate and give you the business model version to begin with, it's very difficult to, well, I would say even impossible to build a data model that's accurate, that you can guarantee is accurate if you haven't had business sign off. And this is the thing that I realized. Like most of the readers of the book are technical. They're engineers, they're data people. They're, first of all, they might be even fundamentally unfamiliar with business metrics, that the language of what the stakeholders care about. They don't care about type 2 dimensions. They don't care about data governance, even though they say they do. They care about numbers. They care about return on investment, return on their time sitting down with you, explaining something. And not only do you maybe not have that vocabulary as a head of data or as a senior data engineer, you maybe don't even know how to engage the business on terms that they care about, of how to defend a data modeling line item on a on a project or in front of the budget committee and say, look, this is exactly what we're planning to do. This is how much it's going to cost, and this is what it's going to give us in return. And the returns are, often the life and death of your data initiatives, which could be multi-year projects. So these are very important things to get right and very easy things to defend once you just have the common language and tool set to talk about them. So this
So
is one of my favorite chapters of the ROI of data modeling, or the finally like selling it back to the business of, okay, we've got the skills, we've got the methodology. Now let's talk to our business users, and here's a game plan of how we're going to do it.
yeah, and we had a separate webinar session on this particular topic, and I know you had a talk at Snowflake Summit too. So there's a lot of materials available, but I love how it now owns a separate chapter in the book, that you're introducing the KPIs themselves, and then kind of tying the business KPIs to kind of what's happening in the technical language, and then how to put together a business case and present it internally.
Yeah, like those presentations all came out of the book and one that specific chapter of the book. And for me, it was like the biggest validation ever that not only was the session sold out and standing room only, but somebody, speaking of KPIs, somebody from McKinsey of all places came up to me afterwards and said, "Hey, can I have that slide deck? I'd like to present this to some of my stakeholders." And nobody knows KPIs like McKinsey. So if it struck a chord with them, and I'm glad it did, then for me it was like more than I could have expected. So it's really humbling and validating experience.
Yeah, yeah. So that's one, right? The ROI of data modeling. That was a big addition. The second one, you kind of brushed upon it, the Snowflake advancements. So what are, I don't know if there's a way to summarize kind of what are the greatest and latest things that Snowflake added that you're now covering in the book?
Sure. All of the new table objects, so hybrid tables, dynamic tables, Iceberg tables, event tables, all of these things I felt, I mean, obviously some of them were only kind of a very early, very private preview when the first edition was written, if at all. Most weren't even on the horizon at that point. But like everything in, as the book points out, like all of these features are tools in your tool set. You need to know, first of all, that they exist, how to use them effectively, whether you should use them at all or not, or ignore them if it doesn't suit your use case. And these are the things that are now in the new edition. So We can kind of go through them in case people are unfamiliar with kind of high level what these things do. And these are really exciting features, like potential game changers for people on
Why?
the
Why?
platform. All right, let's go step by step, or let's take them one at a time. Let's start with, I mean, we could really start it with any one of these. Let's start with Iceberg. Iceberg is an open table format, and it's actually a file. It's not even a table. It's a logical table. So you create it, you can query it, you can write select statements as if it were a regular table. But it's effectively a file that's open source and not tied to any vendor. It's an open standard, which means Snowflake can read from it, Databricks can read from it. It's an Apache standard, and it's a file that's not even physically inside your Snowflake black box ecosystem. It's sitting in external storage in S3 if you have that, which means you can now have a data source that you maintain and you can instantly share it to just about anybody. If you have multiple cloud, if you're an organization that's maybe you do analytics on Snowflake and ML ops in Databricks or engineering in Databricks or some other platform or in Apache Spark, you can have this table, you can write to it, you can manage, maintain it, and all of these other platforms can consume it without having to connect to Snowflake, no drivers. They just point at the file and they can literally select from the file, read data from the file, depending on who owns the catalog of the Snowflake table, Iceberg table rather. They can maintain it, and Snowflake could be the one, vice versa, doing the reading, etc. So it's zero copy, zero transfer way of zero duplication, etc., zero latency way of collaborating across platforms. And it's a future-proof way if you want to do it that way. And it's just a really cool technology. It's a file that has all the ACID properties of a database table. So it's secure, it's robust, um, it even has time travel and things that like really cool. The coolest features of Snowflake are all in this standard, and that's incredible. So again, if you have that kind of multi-platform scenario in your organization, like that's something to consider that can eliminate whole pipelines of data processing and data transfer just by having it in one place. Another one that is, again, game changing, I think, is the hybrid tables, which are the reason they're called hybrid is because they're two-in-one solutions, OLAP and OLTP, analytics and transactional, all in one object. So what appears to the user as one object. Under the hood, they're actually two separate tables, and one is optimized in real time for analytics and grouping and summing large amounts of records, and the other one is optimized for um, point reads and writes for specific individual record updates or inserts or just findings. So things that would previously be use cases confined to a transactional database like a Postgre can now happen in Snowflake. So you can build use cases for and you can build a whole application that writes its transactional data, its operational data to the hybrid table. And your analysts could be, again, this is something you can't do in a transactional OLTP system. Your analysts could be monitoring that data in real time in aggregate, which would normally cause contention issues. That's a big no-no on a transactional system. But here you get the best of both worlds. And which also means for the first time, again, how is all this, how is it possible to be fast at individual records and also aggregation? Well, the aggregation works using the kind of the bread and butter of what Snowflake is famous for. It's a service layer. It's a columnar architecture. And the transactional bit works with indexes the way it's been done for decades. For the first time, we have indexes in Snowflake which a lot of people, they can't live without them. And indexes just they open the door to things that people have criticized Snowflake for, not being a real database because they don't enforce referential integrity. Well, now they do. And of course, it comes at a performance cost that you're again, there's a premium you pay for this type of table because it takes up twice as much storage. It's a special kind of object, but again, the use case justifies or doesn't justify the cost because otherwise, it might be more expensive than a traditional table, but it's a hell of a lot cheaper than maintaining a separate database, moving data across and analyzing it, etc. So that's two. And the third one is dynamic tables. So dynamic tables, these unlock, they're effectively giving you ETL or pipelines inside of Snowflake. So for many people in practical terms, they compete with dbt, which curiously enough, Snowflake now also supports. But we're not gonna venture there on this webinar. But dynamic tables are really cool. They're kind of like materialized views where you have an imperative statement that says, select column one from here, column two from there, concatenate from here, join with this other table. But unlike a view, materialize this into a table. So Snowflake kind of had something like this with materialized views, but those are really only for single sources, and all they're really good for is kind of aggregation, maybe. And I mean, we can get into those separately. Dynamic tables can be
Yeah, you
changed.
have to leave out some of the context so that people
Yeah.
read the
Yeah,
book.
that should give people a
And
reason to read the book, right? No, but dynamic tables, you can create whole pipelines out of them. So you can have one dynamic table reference another dynamic table, reference another dynamic table, and you're no longer having to orchestrate and time and schedule. You just give them kind of how how fresh do you want the data to be? Like a maximum of this needs to be maximum 1 minute out of date or maximum 2 hours out of date. As soon as the source changes, I want this to change. And of course, you can also do this manually, trigger on demand. The book goes into kind of hacks to make that work as well. But it means that you no longer need a third-party tool. You don't need a DBT necessarily if you haven't already invested in DBT. You don't need other ETL tools to orchestrate your runs because at the end of the day, that is kind of critical database functionality of you can bring the data in, but how do you get it to refresh at the right time, at the right place? And dynamic tables are now a really easy to manage, cost-effective way to do that, especially considering it's all in the same platform. You're not relying any longer on third-party tools. Okay, so I know you're like I've kind of already gone a little bit too far on details. So
thank you for covering, because I love the fact that how knowledgeable you are about Snowflake itself and how you kind of like meshing it together in the book. So I see it as a dictionary almost of both data modeling terms and also Snowflake functionality, the table types and the capabilities and tips and tricks. So it's kind of like it almost serves as a one source of knowledge for both. How would you summarize the connection, the differences and connection between data modeling, as it in a more traditional sense, and semantic modeling? What should we know about this?
yeah, great question. Because there's, again, to somebody just starting out and you hear, okay, I want to learn about data modeling. Wait, it's not data modeling, it's conceptual modeling, logical modeling, transformational, semantic, data dictionaries, data glossaries. So, what is semantic modeling? The good news is all of these things kind of flow, they're very, very similar. So there's obviously nuances, but once you have one, you can very easily derive the other. It's not reinventing the wheel. It's all much of the same information, just presented in different formats. A semantic model is, if you can think of data modeling as I highlight in the book, data modeling is really business modeling. It's finding a layer or a set of language and visuals and to not misuse the term semantics that you can communicate with people, with your business users and say, and just have an easy way to validate of, hey, when you say this, do you really mean this? And instead of words in the air, it's something definitive on a page or on a diagram that someone can instantly say yes or no, or this is what I really meant. So it's more human focused, data modeling is. The issue is once you start to plug in reporting tools, AIs, AI is not going to be interested. Well, maybe AI is, but a reporting tool isn't going to know how to read your diagram. It needs that information in something that's a machine readable, a little bit easier, a bit more structured and formal in its standard. So a semantic model is just a way to communicate your data model to some third-party system that's going to automatically be able to interpret words and turn those into specific SQL statements that can actually run a whole query just based on a natural language question or a prompt. So in the scope of my book, again, there's unfortunately like with most of our data industry, there's lots of standards. There's no shortage of standards. You just have to pick one and go with it. There's no universal formal semantic layer standard, at least not yet. But Snowflake has a really cool feature called Cortex Analyst, and Cortex Analyst is their AI, their LLM that will let you speak to your data and put it in front of your business users. Instead of giving them a dashboard, you basically give them a chat or an API that they can just ask questions to and say, what was the revenue by customer or by region for the last 2 weeks? And the semantic model will translate that into exactly what is a customer, where is the customer data, what is the revenue field? When you say weeks, do you mean load date or transaction date? Obviously, transaction date. So things like that are all encoded in the semantic layer. So the easiest way to describe it is if you think of a data model as a diagram, you can think of a semantic model as the same information, but in YAML. So it's still the physical name of a table, it's still the physical name of the column, it's still how is that table related through a foreign key to another table that you need to join to. It's just in a format that Snowflake understands. And the great news is if you've done your homework, if you've done your modeling, then it's only one or two things that you'll need to add to the semantic model to complete it for once you have your physical model in place. So again, a physical model is something that the database understands. So beyond columns, comments, foreign keys, relationships, the database doesn't understand nuance. It doesn't understand synonyms. It doesn't understand what a named filter is. Like when you say North America, is that a specific value or is that a grouping of countries? So these are things that are just not in the physical standard, but they are in the semantic model standard. So Snowflake's Cortex is just one of many semantic models. dbt has a semantic layer. Many analytics tools like Power BI has a semantic layer. They all follow their own conventions. So the way these properties are named will vary, but the concept is exactly the same. It's the information that's just machine readable or more optimized for machine readable. As a human, you can read this YAML and get a very good idea of what's going on.
And is it true that now with semantic modeling, you don't necessarily have to do logical and physical data modeling?
No, and that's the misconception that we want to dispel because it assumes that when you're talking about a semantic model, you can think of it as a journey, a spectrum of you need to crawl before you can walk, before you can run. And the semantic model lets people run very quickly, and which could be good, could be bad if you run into a wall at full speed. So a semantic model, you can think of it as sitting on top of, the shoulders of all these previous steps that you'd have to go through to build the to take, let's just start from the very beginning, to take what we do as a business, the business model, and understand it. So we form a conceptual model in our heads. Again, it doesn't have to be formally on paper or anything like that. Just the conceptual model of the business could be in our heads, could be in Excel, could be anywhere. Moving that through into a logical model. Again, you're not going to need to do this for every single design you do. If you're small enough, then maybe modeling doesn't make sense for every single feature. I'm just talking holistically. In large organizations, this is going to be a must. This is going to be a standard. And because even when you have something like logically, like a customer, that you probably have multiple systems, you have probably multiple databases where this entity exists. It could be physicalized as one table or multiple tables. So to understand it logically, the business isn't going to care that you split it up or normalized it across three different tables. They just have one idea of a customer in their mind. And the logical model is just something that will help them understand it better. Physical model, now this is stuff that the database understands. And like I said, also limited to only what the database understands. So only after you've gone through those steps that you can just convert that into YAML and add a few other parameters like synonyms and filters, and you're done. You can use AI. You can get AI to accurately answer your business questions just because you've done the very simple task of outlining your DDL, your columns, your joins, your foreign keys. You validated it with the business because this is, in fact, one of the examples in the book. Even basic things like that North America example was taken from experience. If you don't actually have a column called continents and you've a value called North America, and it's, let's say, a business grouping of, where you sell, which countries you sell to, what your business considers it to be, it's North American operations. This is something that would go in your semantic model. And if you don't have that, AI will just take a wild guess. And it was grouping Peru and Mexico and Canada when it tried to build the query without the semantic model, without that information in the semantic model. So even simple things that to us might appear obvious, this is really just taking your business rules and formalizing them. Like when my business stakeholder says North America, they mean US and Canada. And it's as easy as that. So this is why, I guess now if we want to pivot into the topic of AI, like why is this so important now? That getting the right answer has always been what we're interested in, right? So what changed? What changed is the cost of getting the wrong answer. The cost of processing data, as I'm sure everyone on this call is aware, has been plummeting for decades. Cheaper storage, cheaper processing, cheaper compute. And when you have things that are that cheap, you can often get away with a lot of inefficiencies. So you make a mistake, you reload. Why not store a backup in case we need to reanalyze or come back to a previous state? But when it comes to AI and fundamentally the cost of running an AI operation is much more expensive than running a query. So you definitely wouldn't even want to run that twice if you got an incorrect answer the first time around. But now imagine multiplying and scaling that to training a model or building an impact analysis based on something that AI is predicting or predictive model. If it gets those things wrong at scale, now you're talking about not just a few compute credits, you're talking about hundreds, if not millions of dollars spent in training on the wrong data. Because what is AI fundamentally, as we know it today? What is a large language model? It's a giant prediction machine. It's a pattern matching machine. It goes through multiple, billions of gates of of trying to predict just the next token and match what it thinks you're expecting of it. So why give it extra hoops to jump in when, if you say customer, but you really mean client, and when you mean client, you really mean dim client? Why have it guess all those when you can just eliminate at least that one variable and have it really focus on like what it's meant to be doing, sentiment analysis or predictive patterns or whatever it is you're employing AI to do. So this is something that, again, the simple example I used in my book is let's just it was a very easy transition of in that exact order of, here's the logical, here's conceptual, the physical, and now here's semantic, and here's what AI will give you with semantic, and here's what it will give you with a poorly built semantic model, and it's a stark contrast. So
Yeah,
yeah,
I'm so glad you said it and I have this recorded because I just imagine cutting this out as a snippet and posting it online.
sure.
I have a question from the audience. Any feedback in the book on the future consolidated warehouse that Snowflake will provide to reduce cost and leverage performance of the data warehouse models?
The way I understand it is basically what tools is Snowflake giving you to make sure your budgets don't run away from you and you're building things that are meant to be um, built and used the way that you intended. And again, that's a whole webinar in itself. Again, the way I understand the question, first of all, there's all of the telemetry and the monitoring that Snowflake offers. So things like event tables that are also covered in the book of making sure that if you're building applications, you're capturing all of the inputs and outputs and logs. There's the monitoring and budgets that you can now enforce. So before you kind of just had the warehouse and you gave it to your users and hoped you constricted it on size and use case. Now you can actually give a team a budget and say, do whatever you need to do, but you have this many credits to spend. And not only is that from a practical perspective, kind of keeping you safe, meaning they can't overrun and generate a massive bill at the end of the month, but it also means that again, it's no longer a shared resource. You can ask them, okay, they come to you, they ask for, let's say, $1,000 a month of compute credits. You can actually bring that to a planning committee and say, what's going to be your output? Are you going to save time? Are you going to increase sales? And if the answer is no, we're just gonna like highlight something on our contracts or contractors, like then you can have a reasonable answer to say, yeah, maybe we don't do that in this way, we do that in another way. Or maybe you need more budget because what you're planning is just resource intensive, but vital to the company. Um, and we have the feedback of professional services shared with us that in the coming months, we should have a kind of AI warehouse management. But this is a future feature. Okay, I see what you mean. I mean, it's pretty much what I'm saying. It's budgets what before you used to have on warehouses, now you have on AI spend because for that very reason, the two are right now in the same bucket, but they're very different beasts. One is obviously more expensive than the other. And another question, yeah, so we're building a data model at our data warehouse layer and then apply a kind of star schema or snowflake mode at the data mart layer and then consumed by our BI team. So is this okay for you guys? I'm gonna throw that question back to you. And is this okay for your users and your BI team? So there's not a one size fits all. So one of the things I kind of highlight in the book that it really depends on the data maturity of your end users. And even then, it's probably not one answer. It's many different users and many different solutions for different needs. So your very, very end users might need something that is maybe even more normalized than a star schema because maybe they don't know, like even joining two tables together is too much for them or gives them room for error. Maybe they need the KPI already pre-calculated and ready to be consumed directly. And maybe in parallel, you have, an analytics team that's quite capable, and they can build their own dashboards and come to their own KPIs. But now you have the task of the data is not pre-cooked, therefore not pre-governed and pre-authorized or pre-validated as it would be, let's say, at a reporting layer. Okay, so
Serge, I have another.
yeah.
Sorry,
No,
we'll come back to Martin. I have another question. What type of functionality does SqlDBM exactly have to integrate with DBT? I know this is a big question. Where should we point the audience for DBT related materials? What's the best place for them to go to?
come to our website and look at some of our DBT functionality there. Check out the documentation, but I can kind of highlight high level. SqlDBM is integrated with DBT, so after you've built your models, you can output them as DBT sources and models. All of the information that you've already built could be inbuilt into the configuration of the data contract. So all of the things that you would expect, you can basically make them asserts in your DBT project. And as of next month, we're releasing manifest import. So that's going to give users the ability to import their DBT projects and configs and effectively link their objects with what's in their DBT project. So you can see not just your data architecture, but you can visually see what's a source, what's a model, what isn't part of your DBT project yet, and be able to then generate specific models and files, basically cross those two together. So it's going to, for the first time ever, like give DBT users a holistic view of their data landscape that no other tool has.
Yeah, I forgot about that. That's coming next month.
Yeah, coming soon and next month. And there's also a question, can we deploy SqlDBM to Snowflake and CI/CD? Absolutely. Yeah. So SqlDBM is a full-featured CI/CD compatible tool. We can push to Git. We have an API. You can automate this any way that suits your business needs. So yeah, we can definitely dive into specifics of SqlDBM and or just reach out to us and we'll be happy to show you.
All right, perfect. And last but not least, Serge, what else to expect from you and SqlDBM's product team in the coming months? You just gave a little shout out to DBT Manifesto. Anything else you're specifically looking forward to?
Yeah. Again, AI is the hot topic, and AI is going to be the next thing that we publicly announce. And we're really excited about it. We have a lot of really cool AI features that we're currently beta testing, and they're showing like really positive results. And besides that, I already mentioned so we're actually going to, right, we're going to do a separate webinar just to showcase everything that we're doing in the AI space in the coming month or months. And on the product space, just again, we've talked about DBT. We have enhancements coming for integrations for Calibra. We have enhancements to our API that's going to make it a lot more powerful. And you just, again, if you're curious about that, check out our website. We have a change log every month, and usually several times a month we release features. So a lot of exciting stuff planned that personally I can't wait to just get my hands on it. I know it's a lot of these still in testing and beta, but really exciting, cool things.
Thank you everyone who joined us live and who's watching the replay. And until next time.